All right, so today we're going to talk about graphing some simple polar equations. We talked uh, yesterday in our last lesson about just graphing points on the polar grid, but today we're going to graph equations, some of them very simple. So let's take a look at the first couple here. And the first one, it tells us that r is 3. They're not giving us, remember, a polar coordinate is r and theta. So a point would have an r value and a theta. But this one just has an r value. Well, r is the radius. And if the radius is 3, then we just are going to go out 1, 2, 3. And we could go out 3 anywhere because it doesn't specify an angle. And if I go out 3 anywhere, then I end up with just a circle with a radius of 3. So it is this complete circle around the polar grid. So if all I have is r, I just graph a circle with whatever radius they give me. Number 2 is almost as simple. This one says that we only have theta involved. That means r could be anything I want. Well, pi force is anywhere on this line. I could go out 1, I could go out 2, 3, 4, 5, or anywhere in between. But remember too that I could have a negative angle. Sorry about my dogs. Sorry about the dog noise. Okay, so here's we could go anywhere out with a positive 1 with a radius with a angle of 45, positive 2, angle of 45, 3, etc. all the way around anywhere on here, and I'm going 45 or pi force out. But I also could go -1 pi force, -2 pi force, -3 pi force. So don't forget that when you have this type, it could be anywhere along this diagonal line. Anywhere along pi force, even if r is positive or negative. So we just get a straight line. All right, for example 3, if you remember from our conversions from our previous lesson, we learned that our y value in our switching from polar to rectangular form, we found out that y was equal to r sine of theta. X was r cosine of theta, y was r sine of theta. So basically, this is the short version of this graph. They're saying here that y equals 2. As a rectangular coordinate, it would just be y equals 2. Well, the line y equals 2 is just a line where y is 2. So I could go up 2 and just draw in a horizontal line. That's going to be my graph. Now I am going to go ahead and show you the actual, I kind of drew that line a little crooked, but that's okay. You can see that this is supposed to be a horizontal line at y equals 2. Now, if I wanted to actually find some values for that, we're going to make us a little chart. So I'm going to take this equation here and solve for r. R would equal 2 divided by sine of theta. I'm going to make me a chart here for r and theta. Remember, that's our polar coordinates, r and theta. And since r is over here by itself, I'm going to choose some values for theta. So pi 6, pi fourths, pi thirds, pi halves. We could keep going, but I'll just do those, okay? And so I'm going to take my calculator and just type these in. 2 divided by sine of pi 6, 2 divided by sine of pi fourths, pi thirds, and pi halves, and get these r values. All right, so probably the easiest way to get these pretty quickly without having to retype it over and over again, I'm just going to put this equation 2 divided by sine x into y equals. I'm going to go to my second window, table setup, and put it on ask. And then I will go to my table. If there's anything in there, it's just because you've already done this before, so you may want to hit delete anything that's in there. And then we're just going to type in some angles. So I'm going to do pi 6. Whoops. Hang on. Pi 6. So I get 4. I'm going to put in pi 4ths. I get 2.828. Pi thirds. I get 2.309. Oops. 2.309. Pi halves. I get 2. Alright, so what I want to do now is just kind of show you the plot of those points to show that they should be on this line. Now, since my line's not very accurate, these may not be super accurate either, but here's what we're doing. We're going to go out 1, 2, 3, 4, and around to pi 6. And we're on the line. We're going to go out 2.8, so 1, 2.8, and then around to pi 4ths. We're on the line. We're going out 1, 2.3, and around to pi thirds. We're on the line. And then 2 pi halves on the line. Alright, so that's just proof that this actually does work. You don't have to plot, you don't have to create the chart. All you have to do is recognize that r sine theta is y, and that y equals 2 would be my graph. Alright, horizontal line at y equals 2. Alright, so our next question is going to be the same idea. Remember from our previous lesson that r cosine theta is how we found our x value. X equals r cosine of theta when we're going from polar to rectangular coordinates. And so this equation is just saying x equals -3. Alright, so x equals -3 is going to be a vertical line at -3. So 1, 2, 3. We're going to draw in a vertical line. Probably should get me a straight edge out, but there we go. Vertical line. Now we can do the same thing with this one. We could solve for r. R is going to equal -3 divided by cosine of theta. We can choose some values for theta. So again, if I were to choose pi 6, pi 4ths, pi thirds, pi halves, then I can type this into the calculator just like I did before, just to save some time. I'm going to go ahead and give you these values. When you type in -3 divided by cosine of pi 6, we get -3.5. Pi 4ths, -4.2. Pi thirds, -6. Pi halves is undefined. We'll go ahead and do one more of these. Pi is going to give us 3. One of them was undefined. So, all right, so that gives us some points that we can plot just to ensure that this really is what we're supposed to get. So we go -3.5, -1, 2, 3.5, and then we're supposed to go pi 6, which will put us right here, -4.2. So 1, 2, 3, 4.2 pi 4ths. Right in here. -6 is going to put us off the graph. Pi thirds, which is off the graph, is down in here. And at pi halves, we're undefined, so we can't really graph that. If I went +3, if I go +3, 1, 2, 3, and around pi units, that puts me right here where I started my line to begin with, out -3. So these points are the points that I get when I plug into the equation. But again, you don't have to do all of that if you just recognize that r cosine theta is an x value. So this is just the equation x equals -3, which is always a vertical line. All right, so far all of our examples have been things that we've already talked about, just a radius or just an angle, or these two that we talked about in our notes previously. But this one is a little different. This one is r equals 4 cosine of theta. So I'm going to go ahead and tell you what it's supposed to look like, and then we'll plot some points to prove that it actually works. So this one is going to be a circle, and its center is going to be well, its diameter is going to be 4. The center is going to be 2 units from there. So the center is going to be half of this. The center is going to be 2 units away from the pole, and the diameter of the circle is going to be 4. So here's what I'm talking about. We're going to start our circle on the pole, and since this is cosine, which is an x value, then we're going to go out on the positive x direction, 1, 2, 3, 4. So this is going to be the diameter of my circle, so my circle is going like this. And the center of my circle will be at 2. So we're going to go about 2 units up, which is going to put us right in here. About 2 units down right in here. And then we'll just kind of sketch in our circle. Not a very good circle here. All right, so that's what it's supposed to look like. That's what's supposed to happen. So when you see one of these, the number in the front is going to tell you the diameter of your circle. And if it's a cosine, that's an x value. So cosine is going to be on the x-axis. And if this is a positive 4, we're moving to the right. If this is a -4, we're going to move to the left. All right, so let's plot some points. This time, again, we're going to solve for r since this is all on the same side. So we'll do pi 6, pi 4ths, pi 3rds, pi halves, and this time I'll go with 2 pi 3rds. Okay, so again, just type in 4 cosine of pi 6, 4 cosine of pi 4, etc. You can use the same way that I did it in y equals and use the table. So we're going to get 3.4, 2.8, 2, 0, and -2. So let's plot just a few of those and see where we land. So 3.4, we're going out 1, 2, 3.4, and around to pi 6. Well, that's right in here, so means I have a decent circle. Then we have 2.8, 1, 2.8 puts us almost out here to 3. We're supposed to go to pi 4ths. Well, that's right in here. Then we have 2, and we're supposed to go to pi 3rds. Right here. 0. And then we have -2, 2 pi 3rds. Which is going to put us over here. So we can see that this actually does give us, if we plotted all the points in between, all the angles in between, a circle. So again, now that we know that, I'm not asking you to plot all the points, just to recognize this form of the equation is going to give us a circle. If this is a cosine value, then it's going to be on the x-axis. This will give you the diameter of your circle. So with that same thing in mind, let's look at this last example here. This one is going to be a circle. The diameter is going to be 3. right here. But this one is sine. And since it's a sine graph, it's going to be on the y-axis. So instead of going out 3, we're going up 1, 2, 3. So 1.5 would be the center of my circle. So this is the center of my circle, full diameter. So I need to go about 3 units and 1.5 units each side. So we're just going to have to kind of approximate that somewhere in here, and we'll try to draw a good circle. Alright, so this is what we should get, but again, we can check the points for r and theta. I'll do pi 6, pi 4s, pi thirds, pi halves, and we'll just check a few of them. So again, if I type in 3 sine of pi 6, I'm going to get 1.5. 3 sine of pi 4s is 2.1. 3 sine of pi thirds is 2.6, and 3 sine of pi halves gives me 3. So we're going to go out 1.5 and go to pi 6. We're going out 2.1 to pi 4s, and in here we're going out 2.6 to pi thirds. That one's probably a little too far in, but right in here. Out 1, 2, 3 to pi halves. So that's the outside circle, and then we'd work our way back in if we did some more angles. So there we go. Sine is going to give us a circle going up on the y-axis. If this is a negative value, then it will go down on the y. Cosine is going to give us a circle on the x-axis, positive to the right, negative to the left.